Greetings, everyone. So this is the third and the last section of the conversation on design thinking. So far, we've talked about 10 different components or elements of design thinking. Today, we'll talk about the last 5 of the 15 that make up what design thinking is. So these 5 are the design thinking is inspired by serendipity, it's traditional as well as modern, it's convergent and divergent, it's at ease with ambiguity, and finally, it breaks standards, it's standards breaking. So these 5 we'll discuss in a bit more detail now. As you've done with the mind map, you've drawn this mind map is 10 with 10 of the design principles so far. Let's go ahead and add the last 5 to this map as well. Okay, let's jump into it. So the first one, or the 11th one, is that design thinking is inspired by serendipity. So this term serendipity essentially refers to the word accident, a happy accidental discovery. So what happens in many cases with design is that you have to make unexpected connections. You have to make connections that you might not otherwise see in the world, and those connections lead to unusual and creative solutions that you often might not think about at the beginning of the process. Another design thinking principle is that design thinking is traditional as well as modern. It looks at the past, but it also looks at the future. Very often when you're designing something new, you're coming up with a new idea, you might be using a new technology, there might be an emerging technology that you might be using, some new materials, a new problem. But it's also important to keep in mind that there always is a history, there's always a past. It's important to build upon the past, look at the present, and plan for the future. So one key thing about design thinking is that it doesn't reject or ignore the past, it actually takes the past, builds upon it to create something for the future. It's really important to think about that. Another thing about design is that design thinking is convergent as well as divergent, right? And this is the process as it unfolds over time is at times wide in the way it approaches the problem and at times narrow. We'll talk about an example at the end of this presentation, but when the process of design starts, we've talked about this before, design is not a linear process. It doesn't go from point A to point B in this sort of a line. It often is very iterative. This is what happens with the design process. However, if you look at this closely, when the design process starts, there often is a ton of ideas that are coming into play. So you might have lots of research inputs that are coming in, you might have multiple people involved. So these things start feeding into the design process. So it is divergent at the beginning, it starts narrowing down. You might do some more research, you might extend out, you might explore some more options, so the process goes outward again. It goes out like this. You might discover that this is an important strand to think about, maybe this is an important thing to think about, so you start narrowing your process again. The process converges. Then you might say, okay, I need to develop a few more solutions from here, you might diverge out again, maybe not as much, but to a certain extent, and the process goes out this. Again, you might say, okay, this is the most promising one, and you go convergent again, and the process goes like this one more time. So as you start, you go divergent and convergent, all along the process till you come up with one final solution. So this convergent and divergent process is a key part of just how design unfolds over time. Design thinking is also at ease with ambiguity. So what this means is that there is an enormous amount of qualitative information that you start with when you start the design process. And sometimes you have to make sure that ambiguity, that uncertainty doesn't unnerve you. You have to be comfortable with that ambiguity. So this is a diagram of the design process as described by a designer by the name of Damien Newman. So if you look at the early part of the design process, this is extremely confusing. There's a lot of back and forth and lots of complexity that you see in the process. That's typical to the design process. For example, if you're designing something that is to be used by children, for example, you don't know what children's needs are. You might not know the development process of children. The first step of the process is to learn about children, to learn about the development process, to learn what might work and might not work. At that stage, there's an enormous amount of ambiguity. You don't know what research you exactly need. You don't know what your solution might look like. But that ambiguity in the beginning of the design process is critical and is essential, and it's something that happens every time a new project is undertaken. But as the design process moves forward, things start to get a lot more easier, clearer, and simpler. I don't think it ever completely flatlines like this. There's always some amount of ambiguity that remains, but for the most part, it's a lot less than it is before. So this is an important thing to think about. In the design process, you have to get comfortable with that ambiguity that exists in the design process. And then one important thing to think about is that design is standards breaking. Very often when you have a new idea, very often when you have an innovation that you're developing, there might not be the right kind of metrics to measure it. There might not be the right kind of standards to look at it by. So it's important to hold your measurement, come up with ideas, explore them, try them, prototype them, experiment with them. Then, as the idea gets developed further, you might consider how to measure it, what metrics to bring to bear. But initially, it's important not to be too quantitative, not to measure too early. Take some time. And I'd like to introduce a quote by Albert Einstein, which says, "Not everything that counts can be counted, and not everything that can be counted counts." So what essentially he's referring to is that something might be extremely important, but you can't measure it. And some things can be measured, but they may not be important. So again, the key thing to keep in mind here is the fact that you have to measure, but it's important to keep in mind that you can't measure too early. You have to wait, let something develop, try it, prototype it, test it, and then start measuring its impact. So we've talked about 5 different principles of design thinking in this lecture, in this presentation, which adds up to a total of 15. I'd like to end by giving a quick example and revisiting the definition of design thinking. Design thinking is a form of integrated problem solving that uses both artistic and scientific thinking with the goal of improving life on Earth, life on the planet. Not just for humans, but for all organisms with whom we share this planet. So for these 5 principles that we talked about at the end, here's a quick example. So what you see in this image is something called an SCBA, or a self-contained breathing apparatus. So students that were working on this project discovered that firefighters, when they're fighting a fire, when they have to run into a burning building, always have to carry this SCBA with them. Essentially, it's an air tank that allows them to breathe. So there's a nozzle that comes out of the tank, it goes to their face, and they're able to breathe air as they walk into a burning building, or as they run into a burning building. The students discovered, by doing research and by talking to firefighters, that very often the equipment is designed for men. They also discovered that over the past several decades, there have been more women in the US who are entering the firefighting force, and so the firefighters are not just men, but they're also women. And because most of the equipment was designed for men, some of it was uncomfortable, maybe too large, maybe too heavy, just not appropriate for the women. And therefore, one of the students' teams designed this new SCBA, which has a lighter air tank. The other option in this is that you can either put 1 tank or you can put 2 tanks in this. You can replace the one with 2. So depending upon how much weight you want to carry, how long you're going to be in the fire, whether you're a man or a woman, you can adjust to make it appropriate to you. So what you see here is you see some of the principles of design thinking we've talked about in this presentation applied in the solution. The student made lots of interesting connections between what was happening in firefighting and other emergency medical technician disciplines. The students looked at the traditional things that firefighters had developed, but also looked at what new materials could be used. So for example, in this case, the shape of the air tank is similar to the traditional air tank, but it is made out of carbon fiber, which makes it a lot lighter and a lot sturdier. The other thing that the students did was they went through this process of convergence and divergence. Initially, they talked to several firefighters, did lots of research, and then started narrowing down on the problem of finding solutions for women. They talked to women, did a lot more research, then they zoomed in on the solution of the SCBA. So the process of converging and diverging happened continuously with the student team. They also had to deal with a lot of ambiguity at the beginning. When they first went and talked to firefighters, they were presented with a range of problems. They didn't know what to focus on. Eventually, they decided to focus on this particular issue. And the idea that it's standards breaking, it's something new, it's something different, it's something that has not existed before. So these are some of the design principles of design thinking that have been applied in this project. I hope the 5 last principles have been clear, and I hope you learned about design thinking, or these 15 principles that make up what design thinking is through this set of presentations. Thank you.